Hello everyone. On behalf of Royal Education Council and Ministry of Education, we would like to welcome all of you to this wonderful online course on Scratch coding workshop. And this workshop is for the teachers who will be teaching ICT curriculum in classes PP to 6. And you'll come to know more about why we are giving this course on Scratch coding. So let's proceed with the course. We have this course on Scratch and you have to know that basically if you are new to this Scratch coding, you would be very excited to learn more on Scratch, because this Scratch is targeted to children in terms of learning coding. So if you look at the screen here, you will see that there's a imagine, create and share. This is some kind of a slogan for Scratch, where in order to develop something, in order to create something through coding in Scratch, you have to first imagine, then you create it, and then you don't leave it after there. Then you have to share that with your friends or colleagues. So in this quick presentation, I have this. The first one is what is Scratch, and second one is why Scratch. Why do we have Scratch in our curriculum? Why children should learn Scratch in primary school? And third one is learning Scratch. How should we learn Scratch? Okay. And the fourth one is some of the programming structure related to Scratch. And finally, we'll also introduce you to the Scratch interface. So coming to the first one, what is Scratch? Scratch is a block-based visual programming language. So that means Scratch, the code in Scratch are in the form of blocks. Then with Scratch, what you can do, you can create interactive stories, you can create animation, you can create games, and you can see this. Stories, animations, and games are something that children are very excited about. The reason why we go for Scratch is you can see that with Scratch you can also share your output or your projects, because there is an online community, Scratch online community, which you will be here. Millions of Scratch projects are being shared by the users. Okay? And basically the users are children children from different countries. And with Scratch, you can help young people. So basically, Scratch has this something called Scratch is designed for children to think creatively, okay? And not only thinking creatively, they also reason it systematically, and it also allows children to work in team. So this Scratch program is developed by MIT Media Lab. MIT is Massachusetts Institute of Technology in the US. And there is a media lab called Lifelong Kindergarten, which is led by a person called Mitchell Resnick. Mitch, people call him Mitch, okay? And he's the person behind the Scratch, okay? And the first Scratch version came in 2003. So Scratch is intended, okay, it is designed to teach coding to the kids in a fun way. So basically, Scratch will help children develop the coding foundation, which they can apply in the higher classes. So this is about Scratch, okay, a brief introduction on Scratch. So you will come to know more of Scratch as we go along the course. And then why Scratch? Of course, we already discussed some components why we have to go with Scratch. So you can see this, the number one is Scratch enables students to create projects that express their ideas. So we know that children will have lots of ideas. Okay? Now, if they want to express their ideas, Scratch gives a platform for them to create that. And then Scratch also helps to communicate ideas for children in different subjects. So children can come up with their projects and they can share it. The project can be shared with others. They can collaborate as well. So students develop fluency through exploration experience. As children create projects, as children share projects, what happens is they get this opportunity. To develop the skill of exploration, and then they will have more experience. And then Scratch enables students to learn coding and develop computational thinking in a fun way. So you can see these. You'll come to know about coding. You will come to know about what is meant by computational thinking. Okay. And if you look here, I think this came earlier also somewhere, that Scratch opens up the opportunity for your students to become creative communicators, computational thinkers, and empowered learners. So this tells us that Scratch is designed for children to to develop 21st century skills, to become independent learners, okay, and also to become efficient communicators. So we can explore more on Scratch, on the Scratch website, the official Scratch website, that is scratch.mit.edu. So moving forward, how do we learn Scratch? Okay, so if you look at this video by Mitch, we talked about Mitch, right? Mitch Resnick.
In developing new technologies and activities, my mentor Seymour Papert often emphasized the importance of low floors and high ceilings. For technology to be effective, he said, it's important to provide easy access for novices to get started, low floors, but also ways for them to work on more sophisticated projects over time, high ceilings. As we've developed Scratch, we followed Seymour's advice, but also added another.
You can watch this video from the YouTube. We have also shared this presentation with you, so you can download the presentation and you can watch the video. So basically what Mitch is saying here is that to learn Scratch, basically you start from low floor. So you start from the basic foundation. Basically, it has to start with easy tasks, okay, to learn Scratch. And then do you keep it there? No, you have to have a high ceiling, which means the standard has to be higher, okay, of high quality. So children has to reach to the high ceiling gradually, and then they do not go with one type of project or one type of animation or one type of tasks. Okay, they must have a variety of tasks. So sometimes they can have music, sometimes they can have animation, simulation, they can also create stories, they can create games. So basically this talks about white walls. So it has to be diverse project. So children get this opportunity to start with small, simple, and then as they go learning with Scratch, they should have also complicated. They should come across more projects, projects that are exciting, projects that are quite of high quality, and then the project should not be on one theme, or maybe it should not be all of games or animation. Should be, there should be variety, so which is meant by white walls. So we have to keep this in mind, that in learning Scratch we should start from low floor, high ceiling, and white walls. Then again, Mitch also talks about Scratch. How do we enhance this creative learning? So he talks about 4 P's creative learning. So again, I will not.
When discussing how we can help students develop as creative thinkers, I often talk about the 4 P's of creative learning: projects, passion, peers, and play. We need to provide students with opportunities to create projects based on their passions in collaboration with peers in a playful spirit. Recently, I've been thinking a lot about a 5th P, purpose. Students are going to get more deeply involved.
So again, I will keep the video here. So basically, Mitch talks about to promote creative thinking or creative learning in our children. So Scratch is a very wonderful platform. So what are these 4 P's? So basically, it's the project. That means when you teach children to learn Scratch, it should be from the project-based approach. Basically, we have to provide children with a project, so they come up with a project using Scratch to build up that. That will enhance creative thinking or creative learning. Okay. And second one is that we should also, before we actually assign the project or a task to students, we should build passion in students. That means if children want to do a project should be on a topic which is of their choice, of their interest, not assigning a same project for everyone. So there should be an opportunity for children to build a project that is of their interest, that is relevant to their context. So that way it will further develop creative thinking. And the 3rd P is peer. Usually when you do projects or when you do work or tasks in groups, there are lots of learning happening. So basically, if you assign work, if you assign projects in peers or in groups, so children will again enhance or develop creative thinking. And the 4th one is children should be able to do these projects. Okay, basically children should be able to learn Scratch in a playful manner. It has to be fun. It should not be something like the teacher all the time talking and doing everything for the students. It should be some elements of fun. Okay, some elements of game or play has to be there so that it will further enhance the creative thinking of children. Mitch also talks about the fifth P, okay? And fifth P he talks is the purpose. So if you allow children, or if you give opportunity for children to create a project that is meaningful, let's say if they create a project in Scratch on waste management, so that is again so meaningful, it adds a value. Or maybe if they want to put across a message on maybe exercising, importance of exercising regularly, maybe the falling or taking advice or taking care of the parents in a story. So there has to be some form of a meaning or the purpose. So that will further enhance the creative thinking. So if you, there's again video shared here. So where a student in US, he and a team of
I remember
boys,
reading the news.
he and a team of boys, what they do is they come up with a Scratch project. But it is this project was I think inspired by an incident in US where there was a gun shooting in a school and the children were killed. So their message was on basically on their feelings on how this kind of situation can be stopped or prevented. So this is a animation again created by,
And thinking,
it's really, you can see they have created an animation. So this is another example of the purpose in terms of the projects in Scratch. So this is on the purpose. So how do we help kids get started with Scratch? Okay. Now, how should we do this? Now, in our case also. So basically, what I'm saying is, how do we teach Scratch? So we should keep this in mind that in teaching Scratch, we should make sure that kids have the time and space to experiment, explore, and express themselves. So basically, give children opportunity to think of what they wanted to do, what they wanted to learn. And then they give them opportunity to explore on their own. Give them the time to express their feelings, their observations. So in learning Scratch, there should be opportunity for children to experiment, explore, and express themselves. And how do we do that? Okay, so one way is to motivate children by giving them projects which are relevant to their setting. So in a way, if they're learning science, make the children create a project on science, but using a Scratch. Or maybe if they're learning language. So if they're learning social studies, and if they have to talk about a field trip in their community, so they can create a project in a Scratch. So that way you can motivate. So here it's talking about integration. And then I think the other approach we should follow in terms of teaching Scratch to our children is to exploration, not with explanation. I think sometimes you don't have to even tell them what are the blocks in the Scratch or what are the codes in the Scratch. Give them the opportunity to explore, and then maybe it has to be student-centered learning. So these three areas, if you look at these three areas, one is giving opportunity for children to explore. So explore, experiment, and express. So communication, independent learning, and then even making mistakes. Experiment is also making mistakes. And the second one here is integration in other subjects. And final one here is student-centered, learner-centered kind of approach. So this is how we can help kids get started with Scratch coding. So coming to the fourth component, so Scratch structure, programming structure in Scratch. So you will, by creating animations, games, or stories in Scratch, children will be learning about programming. Okay? So basically they will be learning about coding. So coding, in terms of coding, in the higher coding, one component is algorithm. Okay, so the second component is the program. First is algorithm, then there is a program, and then the other concept that is there is a sequence. So what is an algorithm? Algorithm is steps to complete a task. We'll come to it later also. What is a program? Program is a set of instruction written in a language that computer understands. Okay, we'll come to that later. And then sequence, a set of instructions that follow one another in order. So let's come to algorithm. Okay, so algorithm refers to a set of rules or instruction that defines how a work or a task is being executed in order to get the expected result. For example, if you want to cook a new recipe, what do you do? We follow the new recipe and then make the dish to get the result. So if you want to make any dish, any new dish, you follow a recipe and you have to follow from beginning till the end. So that's an algorithm. So writing algorithm for solving problem is crucial part of every programming. So basically, before you actually do any programming or coding, you have to think, you have to plan, you have to understand the problem or the project, and then only you have to plan, work out which comes first, which comes in the middle, which comes at the end. So basically, algorithm enables children or anybody to analyze the problem at hand. So it's an opportunity. It also acts as a blueprint for coding. If you have an algorithm, coding will be much easier. You just have follow the algorithm and then you can keep on coding. And then it also helps in debugging. Debugging is when you have problem in the code, when your code is not working, in the sense when you don't get the output as desired. So that's called that's when there is a bug. So to solve that bug is called as debugging. So algorithm will help in debugging. Okay? Algorithm also helps to promote effective communication between team members. So if there is one algorithm for all the team, so by looking at the algorithm, it will help to communicate between the team members. Okay? So algorithm also becomes a part of a software documentation in case if you have to refer what you have actually planned in the beginning. So algorithm helps in that. Okay, so let's look at an example of algorithm here in the real world. Okay, so here you can see this. If you want to go to the market to purchase a pen, what will you do? You start with first from home. You get dressed. You check your wallet for money, whether you have money or not. If there's no money, then you have to look for it. Okay, and then you have to go to the shop. Okay, after getting the money, you have to go to the shop. You have to ask for the pen. If pen is not available, you go to step 10. That means go to another shop. But if pen is there, then you give money to the shopkeeper, get pen from the shopkeeper, go back home. Okay, so you can see this. This is a kind of algorithm. Okay. Do you get this? Like again, when you are there in step number 6, if pen is not able, go to 10, you go to another shop, you go to step number 5. That means again you ask for a pen. So basically that's an algorithm. So here's a simple example of an algorithm scratch. You can see this. Here the cat wants to change into a green color. So what is happening here? The cat moves forward 10 steps and then wait for 2 seconds and then change the color to green. So this is an example of a small algorithm in Scratch. Now the second part is a program. When you convert an algorithm, when you actually write codes for algorithm, okay, and it turns into a program. So you can see this. An algorithm written in code is called a program. So in Scratch also there is a program. So this is an algorithm. Let's say this is an algorithm. Move forward 10 steps, wait for 2 seconds, change color to green. It's the algorithm. And you can see this is a program now. So this is a code. So code 1 is move 10 steps. Code 2 is wait for 2 seconds. Code 3 is change color effects by 25. So that means it's changing to green color. So basically this is a program. This is an example of an algorithm. Algorithm has to be converted into program. So how do that? We code it. So that's coding. So when this program is executed, the cat will move and then turn into green color. So the third one is the sequence. We talked about sequence. Sequence, I think we understand what is meant sequence. Okay. So sequence is basically we're talking about order. which comes first and which comes second or which comes last. So that's an order. So if you see here, to create an algorithm, one must be very precise when describing the steps to complete a task. The sequence or the order of that step, those steps is also very important. Sequence is really important. So you can see this when you connect blocks together in Scratch to form a script. So now you're talking about script here. You'll know what is meant by script. You can see here a script is a set of Scratch blocks connected together to form a sequence. I'll show you an example here. You can see this in this script. Okay, the sprite script. Sprite means the cat here. Okay, the character here. The sprite will move 10 steps. It's moving 10 steps forward, and then say hello. It says hello. Okay, it waits for 2 seconds and then it makes a pop sound. So you can see here, move 10 steps. You can see the program here now. The programs are in sequence. So first one is move 10 steps, say hello for 2 seconds, and then play the pop sound until done. Now you can look at this another sequence. Okay. Now the first sequence here is, now we have changed the sequence. The pop sound is coming in the first beginning here. Move 10 steps coming in the middle, and then say hello for 2 seconds is coming at the end. These two are entirely two different programs. The first program and second program are not same because the sequence is different. So here the last one will say hello. So basically the cat will make a pop sound, move 10 steps, and then it will say hello. So this is an example of sequence. So sequence is also another important part of coding. So when we teach coding, Scratch coding in our primary schools, we should keep this in mind. Algorithm, okay, number 1 is algorithm, number 2 is program, and number 3 is sequence. Just to begin with, initially, these concepts has to be developed in our students. And this opportunity is given by Scratch programming, okay. So finally, the Scratch interface. In a Scratch, you would know that the Scratch window, this is Scratch window, okay. And then when you open a Scratch program, you will see this part. This area is called as a stage. So stage means every actions happen here. Anything you make, it will happen here. It's called as a stage. Okay. Of course, in the stage, just now the character is the cat. The character is the cat, and then there's also a background. And then the characters are all called as sprite, and the background is called as the backdrop. So this area is to change the sprite and the backdrop area. You want to change the character and the background will be changed from here. Now this one, this area, the center rectangular column, the center column is the one here in the middle, is for the script area. We call it script area, where you actually do the coding. You bring the blocks from here and then you do coding here. So there's a script area, okay? And then these are the block codes. You will have multiple blocks here, different blocks with the different colors, okay? And then these are the called as block codes, and then this is called as the one at the side, okay, at the extreme left side. This is called as the block categories. Now there are around 9 block categories. You can see with different colors. Some are called as motion, some are called as look, some are called as sound. And then there is also an extra one here called Scratch extension. We will come to this also later. So, and then at the top here, code custom sounds, where you can change customs, and there's a menu for customs and sound where you can edit the sound. You can change the custom, in the sense the looks of the characters or the background will be done here. Okay, so if you look at this, there are 3 things you can definitely alter. One is you can choose the sprite. You can create so many characters. Now sprites are the characters. We'll come to that. Second one is the backdrop. You can also choose backdrops, that is background. There are backdrops in the Scratch library also. You can also create your own backdrop. And you can also even draw your own backdrop. Okay? You can import, you can draw your own backdrop. Even it's same with the sprite as well. And then finally you have is the sound. You can also add your own sound. You can record your sound, okay? And there are sound in the Scratch library as well. So basically, this is the interface of Scratch, and you will have a lot of opportunity to play with this Scratch window. With this Scratch program, you will come across this Scratch window. It will become familiar with you. So that's the end of the first lesson on the Scratch.